Hello dear students, welcome once again to Particle Technology. So you all know that this is the third class of the Mixing and Agitation unit. It is unit number 6. So as we always do, let us go back and see what we learned in the last class. So these are the things that you learned in the previous class. So we discussed about the different types of impellers, in which we learned about the axial and radial flow impellers. We also learnt about the classification of impellers like propellers, turbines and paddles. Then we discussed in detail about the constructional and working details of propeller types of impellers and how we can mount the propellers in agitated vessels. And also we learnt about the type of flow pattern created by a propeller impeller in agitated vessels. So today's class we are taking up the next type of impellers called turbine type impellers, the various types of turbine impellers, the constructional and operational details, and also the type of flow pattern created by a turbine impeller. So in this slide, I am presenting you the simple sketches of the various types of turbine impellers. So in the figure A simplest design is shown, so in which a central hub connected to the vertical shaft and a number of blades, flat straight blades, are fixed to the central hub in such a way that they project radially from the center like this. Okay. So the figure B shows another type of turbine impeller. Here, instead of a central hub, we have a disc attached to the vertical shaft and small flat rectangular shaped blades are fixed to the disc that create a required impelling action on the liquids. Okay, so this is another design in which the blades are in curved shape, which are again attached to the central hub as in the first design. So these type of turbines are called curved bladed turbines. The fourth one is a turbine impeller in which we have seen the same kind of structure as in the third type, that is curved bladed turbine. But here the turbine blades are shrouded with a outer ring called the diffuser ring. Shrouded curved bladed with a diffuser ring. So this is a diffuser ring attached to the curved bladed turbine. So the last one, that is fifth one, is the pitched bladed turbine consisting of rectangular shaped blades projecting radially from the central hub. Here the blades are actually mounted in such a way that they make a certain amount of angle with the axis of the shaft. Okay, so this is another view of the vertical curved bladed turbine that you have seen in the figure C. Okay, so among these designs, the pitched bladed turbine creates an axial flow in the agitated vessel, whereas all other types actually generate radial currents in the agitated vessels. Let us now discuss the various constructional details of turbine type impellers. So as I already told you, the pitched bladed turbine is an axial flow impeller, while the curved blade and flat blade and all other types of turbines create a radial flow. So they are radial flow impellers. Means with pitched bladed turbine, the flow currents generated will be perpendicular to the axis of the shaft. Sorry, with pitched bladed turbine, the currents produced will be parallel to the axis of the shaft. So it's called axial flow impeller. While the curved blade, straight blade and the bladed disc turbine create the radial currents, that are the flow currents which are perpendicular to the axis of the shaft. So hence they are called radial flow impellers. So comparatively, the turbine impellers create a vigorous mixing action due to the presence of strong centrifugal and rotational motions generated by them. So unlike propellers, which are most suitable for low viscosity liquids, turbine impellers are effective for low viscous liquids as well as high viscous liquids. So a stator ring that surrounds the impeller gives an efficient mixing action as shown in the figure D. So you can have a stator ring that shrouds or surrounds the impeller. So that gives a most efficient mixing action compared to the other designs in which there is no stator ring surrounding the impeller blades. So the blades of the impeller may be attached to the central hub or to a central disc. So as shown in these two figures, so this is the vertical shaft to which a central hub is fixed, and to that central hub you can see the blades of the impeller are attached like this, or there can be a circular disc which is fixed to the central shaft perpendicular to the axis of the central shaft. Then you can fix the rectangular shaped blades to the outer side of the central disc. So that is how we can mount the blades in a turbine impeller. The diameter of the impeller will be around 1/3 to 1/8 of the vessel diameter. So this is decided depending upon the type of the impeller. The blade length is 1/4 of the impeller diameter. With central disc it is 1/8 of the impeller diameter. The length of the blade so depends upon the diameter of the impeller. It is usually 1/4 of the diameter of the impeller, and in fact if central disc is there it is about 1/8 of the impeller. So that is the reason why you see a smaller length blades in the bladed disc impeller and a longer blades with a longer length in the open straight blade impeller. The blade angle of the curved blade, okay, so this one turbine may be between 30 to 60 degrees. So that is the angle of inclination of the curved blades in a curved bladed turbine. So the speed of the impeller ranges between 50 to 250 rpm. So these kind of impellers are effective in handling liquids of wide range of viscosities. So let us now understand how a radial flow current can be created by a turbine impeller in agitated vessel. So consider for example the disc bladed turbine impeller, so in which there is a circular disc attached to the central hub of the vertical shaft, and to this disc a number of blades are attached as shown in the diagram. So when just like your propeller impeller, the impeller can be mounted at center if the vessel is baffled, or if the baffles are absent, then to have a right kind of mixing action, that is to have a flow current free from swelling and vortex formation, you need to mount the impeller either in the side or with the angular position inside the agitation vessel. So turbine impellers drive the liquid radially against the wall, where the stream divides into two portions. One of the portion flows downward to the bottom and then return to the center of the impeller from the below, while the other flows upward towards the surface and finally returns to the impeller from the above as shown in the figure. So this is how a radial flow current is provided by the turbine type impellers. Okay. So when this kind of impeller is mounted in an agitated vessel in this way, so it radially pushes the liquid towards the wall of the vessel. That liquid stream, after striking the wall, gets divided into two portions. One stream flows in the downward direction, that is towards the bottom of the vessel, and after getting spread along the bottom, it finally returns to the center of the impeller. So the other stream actually flows along the wall, it is towards the top of the vessel up to the liquid surface, and then it finally returns to the impeller center. So similar kind of flow currents are produced on the other side of the impeller also. So these kind of flow currents that are generated by turbine impellers are called radial flow currents. So turbine impellers are especially effective in developing radial currents, so as we just now discussed. But with a baffled vessel, they also induce vertical flow currents. To avoid vortexing and swelling in turbines, baffles or diffuser rings can be used. Okay? So without the baffles, they create a strong radial flow. So radial flow has a tendency to develop swelling and vortex formation. So with the baffles located in the agitated vessel, so some of these radial flow currents are converted to axial flow currents. So in that way, the baffles help in preventing swelling and vortex formation. So usually, the agitator will be located at a height from the bottom which is equal to diameter of the agitator. So that is the standard method used to locate a impeller in an agitated vessel. So however, the speed decides at what height this has to be used. So if the speed is less, that is if it is to be used for a lesser speed, then the turbine is located at a depth twice the diameter of the agitator or impeller, and if the at low speeds it will be 4 times at high speeds. Okay, so these are the things that are used to locate or to position a impeller in a agitated vessel. So if the depth of the liquid is more than twice the agitator diameter, it is as well advisable to use two impeller on the same shaft. So instead of just one impeller, you can have one more impeller above at a certain distance from the bottom one. So that is the kind of mounting that is used for agitated vessel where you have the depth of the liquid twice the agitator diameter. Okay, so these are the real pictures of some of the turbine impellers. So this is a disc bladed turbine, and these are the pitch bladed turbines. Once again, picture of a disc bladed turbine, and this is a curved bladed turbine. The various views of a curved bladed turbine, and of course this is the pitch bladed turbine. Okay, so this is another diagram showing you how the radial flow currents are generated in a turbine agitated turbine impellers in a agitated vessel. So you can see that two streams are created as the turbine is rotated. The liquid is pushed radially, that is in a direction perpendicular to the axis of the shaft towards the wall, where it gets separated into two streams. One stream flows in the upward direction. After reaching the surface of the liquid, returns back to suction. The same way, the stream flowing downward, after it has spread along the bottom, finally returns to the section, center of the impeller. So with that, let me end the class. So this is what you studied. So let us just go through them briefly. So turbine type impellers are the radial flow impellers, except the pitch bladed turbine impeller, which creates an axial flow. So that is about the different types of turbine impellers. So we have seen various designs of turbine impellers. So the impellers can be created with the straight flat blades or with the curved blades, or with a disc at the center to which a number of blades can be attached in a disc bladed impeller. And also we've seen how a pitch bladed impeller can be constructed. So what kind of flow current is generated by each type of impeller, and what is the dimensions that you need to use to construct a turbine type impeller, all this we discussed. The flow currents, how they are generated in a agitated vessel with turbine impellers, that also you learned in today's class. It's time to go through some of the multiple choice questions. So pick out the wrong statement in the following. So recommended peripheral speed for the turbine impeller is 200 to 250 meters per minute. Which bladed turbine agitator gives only radial flow with complete absence of the axial flow? Generally, the diameter of the agitator is kept between 1/3 to 1/6 of the tank diameter, while the blade length is 1/4 of the agitated diameter. In case of disc attached to the central hub of the shaft, and it is 1/8 of the agitated diameter without disc. So that part is missing here. Okay. So these are the dimensions of a blades and blade length in a turbine impeller. So turbine agitator should be located at a height not less than 1 agitated diameter from the bottom. If the depth of the liquid in the tank is more than twice the agitated diameter, two agitators, that means two impellers. You can say agitators and impellers for the same element. So two agitators should be used. Okay. If you carefully go through all the statements and recall the concepts discussed in the class, so you will find out that the second statement, which says that the pitch bladed turbine agitator gives only radial flow without any presence of axial flow. So this is the wrong statement, because pitch bladed turbine is the only turbine that produces axial flow, not the radial flow. So the right option for the given question is option B. Pitch bladed turbine is a radial flow turbine, an axial flow turbine, neither A nor B, axial flow impeller at high speed and a radial flow impeller at a low speed. So just now we discussed about the type of flow current created by pitch bladed turbine. So pitch bladed turbine actually creates an axial flow, but all other types of turbines are capable of creating radial flow. So option B is the right answer. Okay, so let me tell you here that in the material that I have supplied, maybe this question has been provided with the wrong answer in that one. So this is the right answer for this question. Pitch bladed turbine is an axial flow impeller. Okay, so sorry for the mistake. Correct yourself. So pitch bladed turbine is an axial flow impeller, not a radial flow impeller. The blade length of the flat plate turbine is dash of the impeller diameter. Is it 1/8 of the impeller diameter? Is it 1/12 of the impeller diameter? Is it 1/3? Or is it 1/4? Okay, the length of the blade of the flat blade turbine, not the disc bladed turbine, is 1/4 the impeller diameter. In case of disc bladed turbine, the length of the blade will be 1/8. Okay. So 1/4 is the right answer. To avoid dash in turbines, baffles or diffuser rings can be used. So is it the swirling? Is it vortexing? Is it neither swirling nor vortexing? Or is it both swirling and vortexing? So swirling and vortexing are the simultaneous phenomena. So when swirling occurs only the vortexing takes place. So it is important that we need to avoid swirling and vortex formation because that leads to incorrect mixing or insufficient or inefficient mixing. So baffles or diffuser rings are the elements that can be used to prevent the swirling and vortex formation. That is to avoid swirling and vortex. So accordingly, the last option, option D, is the right answer. Okay, dear students, so that completes the discussion on turbine type of impellers. So let us again meet in the next class to discuss about the paddle impellers or paddle agitators. Till then, take care. Goodbye.